Q241. Mention the potential benefits of Unity malls as proposed in the Indian Budget 2023 in promoting local manufacturing. Discuss the challenges which are likely to be encountered in the implementation. Illustrate with relevant examples. 15 marks, 250 words, core demand of question. Mention the potential benefits of Unity malls in promoting local manufacturing. Mention the challenges which are likely to be encountered in the implementation. ANS. Unity malls proposed in Budget 2023 would be established in the state capital, or the most popular tourist destination in state would be an integrated commercial complex for the promotion of one district, one products, ODOP, geographical indication, GI, items and other handicrafts which are made in that particular state. Example in Unity Mall in Lucknow showcasing and selling Banarasi sari, etc. Potential benefits of Unity malls in promoting local manufacturing. Encouraging local artisans. A Unity Mall could feature a section dedicated to locally made handicrafts, empowering artisans and promoting their traditional crafts. For example, leather toys of Indore, being sold in the Unity Mall of Bhopal, will bring additional sales to the manufacturer of such toys. Fostering collaboration and innovation. It can host a dedicated innovation center where manufacturers can collaborate with designers to create innovative products with unique features. For example, the lock manufacturer of Aligarh can learn how to make their locks more sleek and stylish while retaining its strength. Enhancing visibility and market access. It could have a dedicated section for locally made garments, enabling local clothing manufacturers to reach a wider audience and compete with larger brands. For example, Chanderi saris. Promoting sustainable practices. It can feature a section dedicated to locally produced organic products, promoting sustainable farming practices and reducing reliance on chemical-intensive agriculture. For example, organic red rice from Uttarakhand. Supporting Make in India initiative. For instance, a dedicated section in Unity malls showcasing locally manufactured consumer electronics, encouraging customers to choose Indian-made products over imported ones. Strengthening cultural heritage. It can feature a section dedicated to traditional handloom products, preserving the rich textile heritage of a particular state or region and supporting local weavers. Challenges which are likely to be encountered in the implementation. Land acquisition and zoning. For example, acquiring land in a densely populated city center could be difficult due to existing buildings and limited available space. Stakeholder management. For instance, nearby small retailers might express concerns about potential competition and the impact on their businesses. Financing and investment. Obtaining loans or attracting private investments may be difficult, impacting the implementation. This challenge is further amplified if the proposed budget allocation falls short. Market demand and competition. For example, if the proposed mall is located in an area with an oversaturated retail market, it may struggle to attract customers and tenants. Evolving consumer preferences and trends. For example, if the mall does not keep up with the rise of e-commerce and fails to offer unique experiences beyond traditional retail, it may struggle to attract customers. Technology integration issues. For example, deploying a robust and user-friendly mobile app for customers to navigate the mall, locate stores, and access promotions may face technical challenges. Overall, Unity malls have the potential to revitalize local manufacturing by providing a platform for local entrepreneurs and supporting government initiatives like Make in India with comprehensive planning, effective project management, and continuous adaptation. But to ensure their successful implementation, the persisting challenges have to be dealt with. Q242. Sea level rise is reshaping the national boundaries of small and low-lying island nations and accelerates the chances of degradation of the natural resources, causing more poverty issues. Comment. 15 marks, 250 words, core demand of question. Discuss the reshaping of national boundaries of small and low-lying island nations due to sea level rise. Substantiate with the relevant examples. Explain the acceleration of degradation of the natural resources causing more poverty issues due to sea level rise. Suggest some solutions in the form of a way forward. ANS. Sea level rise stemming from glacial melting, ice sheet retreat, and ocean warming poses severe threats, especially to small, low-lying island nations. The vulnerable geographical positioning of countries like Maldives, Indonesia, and Bangladesh heightens their risk, with the special report on the ocean and cryosphere in a changing climate SROC, projecting a potential 0.95 to 3.61 feet, 0.29 to 1.1 meters, rise in sea level by the century's end. In fact, the Maldives president warned at the UNGA that a rise exceeding 1.5 meters could lead to catastrophic consequences, endangering millions of lives. New boundaries shaped by sea level rise. Natural boundaries many small island nations and states lie at or are just a few meters above sea level, which makes them extremely at risk of denudation. For example, around the year 2100, the Maldives is anticipated to encounter a sea level increase of approximately 1.5 feet and could potentially undergo the loss of approximately 77% of its land expanse. For example, land degradation, the constant increment of sea levels, caused the island nation to lose its productive areas. For example, the island nation of Kiribati in the Pacific experiences such land loss due to sea level rise, affecting its people's livelihoods. Coastal erosion. Submergence due to permanent flooding of coastal areas led to loss of previous boundaries and shift to new political map. For example, Carteret Islands in Papua New Guinea, where inhabitants are forced to relocate due to the encroaching sea, prompting a shift in political boundaries. Acceleration of the chances of degradation of natural resources and more poverty issue. Impact on the primary source of income. Rising seas will swamp farmlands, impacting the fishery sector, which is the main source of income for people, which mainly impacts the local and poor fishermen communities and small-scale business. For example, to illustrate, approximately 680 million people across the globe live in low-lying coastal zones, and the majority of them are involved in agriculture and fisheries, representing their vulnerability. Loss of lives and property. Rising sea level will be more vulnerable to hazards and water-based disasters, which may further lead to loss of life of the breadwinner of the family and their houses, leaving people in more poverty and deprivation. For example, a study by the United Nations estimates that by 2050, around 200 million people globally could be displaced due to rising sea levels and related impacts. Degradation. As sea level rises, island nations are at increased risk of losing coastal arable land to degradation as well as salination. Thus, it becomes very difficult to produce subsistence crops. For example, Sundarbans area in India and Bangladesh. Basic needs increase in sea level will further have impacts on and resources like water, so water supplies will be polluted and more distress, so having affordable water routes will increase. Climate refugee. Sea level rise will displace millions of people much sooner than expected. As per IPCC's 6th assessment report, in coastal areas of different countries like Bangladesh, Myanmar, India, the rate of climate refugees is already increasing. Increasing cost of administration or infrastructural repair. The government resources on administration and infrastructure repair, which reduce the social development budget, thus making people more vulnerable to poverty cycle. For example, shift of Indonesia capital Jakarta. Measures needed. Accountability of carbon emitter nations in the Paris Agreement. The funds needed to ensure the protection and safety must be flown at their parents' level. Nature-based solutions. The nature-based solutions like using wetland and mangrove on coastal areas and natural fencing can help for disasters and loss of lives and property. Man-made fencing. The man-made fencing can also be tried using the semi-porous nature of material. Focus on reducing carbon emissions. The use of renewable energy, use of CCUS methods, reducing the use of fossil fuel energy resources. Better prediction. The early warning system and technological tools like satellite imaging, sensors, and data analytics must be equipped to predict the disaster. In a world grappling with rising sea levels, the fate of small and low-lying island nations hangs in the balance. By proactively addressing the impacts of sea level rise, humanity can work towards mitigating the dire consequences for vulnerable populations, averting ecological and humanitarian crises, and fostering a more sustainable future for all. Q243. Describe the challenges and opportunities of tourism in glacier and ice-covered areas. 15 marks, 250 words, core demand of question. Highlight opportunities of tourism in glacier and ice-covered areas. Mention challenges of tourism in glacier and ice-covered areas. Suggest suitable way ahead in this regard. ANS. Tourism in glacier and ice-covered areas, a segment of the broader ecotourism landscape, involves the exploration of some of the world's most pristine and remote environments, ranging from the ice fields of Antarctica to the glaciers in the Arctic Circle. However, it also raises significant concerns about environmental degradation and sustainability. Opportunities of tourism in glacier and ice-covered areas. Economic growth. Regions endowed with glaciers like Alaska have turned glacier tourism into a thriving industry, facilitating robust economic growth through avenues such as job creation and fostering small businesses. Educational opportunities. Educational institutions like the Glacier Bay Lodge in Alaska stand as testimony to this, offering educational hubs where tourists can enrich their knowledge through immersive experiences, fostering a deeper understanding and respect for these pristine environments. Scientific research. Greenland, for instance, has been a focal point for research activities, where scientific expeditions have gathered crucial data regarding climate change, facilitating better understanding and, consequently, improved policy formulations. Adventure tourism. For example, regions like Patagonia have gained renown for their challenging trekking trails, providing unmatched experiences to adventure seekers worldwide, who are drawn to the challenging yet exhilarating landscapes. Wildlife tourism. The glacier regions are sanctuaries to unique wildlife species, giving tourists the chance to witness rare flora and fauna in their natural habitats. Antarctica is known for housing vibrant penguin colonies, offering a rare glimpse into the lives of these intriguing creatures. Wellness tourism. These regions offer tranquil landscapes ideal for wellness tourism. The serenity engulfing the glacier landscapes provides an excellent backdrop for wellness retreats, promoting mental rejuvenation and peace. Culinary tourism. In Iceland, for instance, visitors can indulge in culinary delights crafted using pure glacial waters, providing a distinct freshness and flavor to the dishes, promoting culinary tourism, where people travel in pursuit of unique dining experiences. Unique experiences. These regions are a hub for unique experiences. E.g., mystical northern lights in the Arctic regions draws tourists from across the globe, eager to witness this natural light display, promoting a special tourist niche focusing on such unique experiences. Challenges of tourism in glacier and ice-covered areas. Environmental degradation. The surge in tourist footfall often leads to environmental issues. E.g., the base camps of Everest are often highlighted for the accumulation of waste left behind by trekkers, reflecting the urgent need for sustainable tourism practices. Climate change. In locations like Greenland, the influx of tourists has been linked to a rise in the carbon footprint, which indirectly speeds up the melting process, posing a grave threat to the glaciers. Safety concerns. Glacial environments harbors inherent risks such as avalanches and crevasse falls. E.g., the Swiss Alps have reported numerous accidents, urging the authorities to constantly update safety protocols and infrastructure to safeguard the tourists. Infrastructure challenges. For example, the construction of hotels and other amenities in the pristine environments of Alaska has raised concerns regarding the degradation of natural habitats and the well-being of the native wildlife. Cultural erosion. The influx of tourists sometimes threatens the erosion of local cultures. Indigenous communities such as the Inuit in Canada find their traditional ways of life being commodified for tourist consumption, which can lead to a dilution of their rich cultural heritage. Resource strain. Popular tourist destinations face a strain on local resources. In places like Antarctica, the large number of tourists arriving on cruise ships has raised concerns about the adequate supply of fresh water and the management of waste, which strain the local ecosystems. Accessibility issues. Many glacial regions are remote and have issues regarding accessibility, which limits the potential growth of tourism. Places like Svalbard in Norway, although rich in natural beauty, face logistical challenges, making tourism development a challenging task. High operational costs. Operating tours in extreme conditions entails high costs, including specialized equipment and trained personnel. E.g., tours in Antarctica require substantial financial inputs for maintaining safety standards and environmental conservation measures. Way ahead. Sustainable tourism. To ensure the longevity of tourism in glacier and ice-covered areas, there is a pressing need to foster sustainable tourism. Introducing eco-friendly lodging facilities, like the dome-shaped lodges that leave minimal footprint, can be a substantial step. Community involvement. Offering training programs to the locals to foster entrepreneurship can ensure a more organic and grounded tourism experience, bringing authentic local narratives and experiences to the tourists while ensuring economic benefit for the communities involved. Research and development. Collaborative international research projects that work on crafting real-time solutions and mitigation strategies based on scientific data should be encouraged to preserve these unique landscapes for future generations. Safety protocols. Comprehensive safety protocols that encompass well-marked safe zones and emergency response systems are needed. E.g., incorporate advanced technologies such as GPS tracking and AI-assisted predictive analyses for potential natural hazards. Environmental education. Interactive workshops and seminars guided by experts could offer insight into the region's delicate ecosystem, encouraging tourists to adopt a more respectful and conservation-centric approach during their visit. Infrastructure development. Using local materials for construction and harnessing green technologies could pave the way for infrastructure that harmonizes with the natural surroundings rather than disrupting it. Regulatory framework. Establishing a robust regulatory framework can help in controlling the footfall in these vulnerable areas. Introducing a permit system based on the carrying capacity of the region can ensure a balanced approach to tourism that respects the environment. Technological advancements. Offering virtual tours through immersive VR experiences can potentially reduce the physical footprints on these fragile landscapes while providing a semblance of the real experience to a wider audience, opening up a new dimension in glacier tourism. With these innovative strides, the tourism sector can strike a fine balance between offering a rich, immersive tourist experience and preserving the delicate equilibrium of glacier and ice-covered areas. It would craft a future where tourism harmonizes with nature, nurturing and cherishing the pristine beauty rather than exploiting it. Q244. Explain the concept of ocean acidification and enumerate into its consequences for marine ecosystems. 10 marks, 150 words, core demand of question. Explain the process of ocean acidification. Shed light upon the consequences of the ocean acidification for marine ecosystems. ANS. Sea acidification is the gradual decrease in the ocean's pH level, primarily resulting from the absorption of carbon dioxide, CO2, from the atmosphere over an extended period. In the past century or so, seawater has become about 30% more acidic, shifting from its traditionally near-neutral pH of around 8. Process of ocean acidification. Carbon dioxide, CO2 absorption. Excess CO2 is released into the atmosphere mainly from human activities, such as burning fossil fuels, coal, oil, and natural gas, and deforestation. These activities significantly increase CO2 levels in the atmosphere. Transport to oceans. Rainwater containing dissolved CO2 and carbonic acid falls onto the Earth's surface, including the oceans. This water carries the excess CO2 from the atmosphere into the oceans. Atmospheric CO2 dissolution. Once released into the atmosphere, CO2 molecules dissolve in rainwater and form carbonic acid, H2CO3. This carbonic acid is a weak acid, but plays a crucial role in the acidification process. Carbonic acid ionization. In seawater, carbonic acid molecules dissociate into bicarbonate ions, HCO3, and hydrogen ions, H+. This process increases the concentration of hydrogen ions in the water, lowering its pH level. pH reduction. The increase in hydrogen ions makes seawater more acidic, causing a decrease in its pH level. Ocean pH is measured on a logarithmic scale, so even small changes represent significant shifts in acidity. Consequences of ocean acidification for marine ecosystems. Coral reef decline. The reduced pH levels hinder the ability of corals to form their calcium carbonate skeletons, leading to weaker and slower growth. For example, since 1950, ocean acidification has resulted in a roughly 13% decrease in the skeletal density of massive porites corals within the Great Barrier Reef. Disrupted food chains. Ocean acidification can disrupt marine food chains by altering the availability and distribution of prey and predators. For example, alterations in pH levels can affect the sensory mechanisms of fish larvae, potentially hindering their ability to detect and evade predators. Impaired reproduction and population decline. Ocean acidification poses a threat to marine species by potentially reducing their reproductive success, which, in turn, can lead to declining population sizes. For example, increased acidity can result in the improper development of sea urchin and oyster larvae, impacting their ability to reproduce and sustain their populations. Shift in species dominance and biodiversity loss. Ocean acidification's regional impact on marine ecosystems varies, causing shifts in species dominance and significant biodiversity loss. For example, in Papua New Guinea, carbon dioxide seeps replaced branching corals with boulder forms and, in some areas, entirely replaced corals with sand, rubble, and algae beds. Increased vulnerability to other stressors. Weakened by acidification, marine organisms become more susceptible to other stressors like rising ocean temperatures and pollution, intensifying the challenges they face. Cascading effects of vulnerable ecosystem decline. As vulnerable ecosystems decline due to ocean acidification, the associated species that depend on these habitats for shelter and sustenance risk losing their homes, which can have cascading effects throughout the food web, for example. The complete depletion of coral reefs can result in the loss of up to 25% of marine species dependent on these delicate ecosystems. Conclusion: Scene acidification presents a significant peril to marine ecosystems, with the capacity to trigger cascading effects that disrupt the delicate balance of marine life. By recognizing the issue's severity, promoting global cooperation, adopting sustainable practices, and advancing research to curb carbon emissions and their impacts, we can strive to preserve the delicate balance of our oceans and ensure their vitality for generations to come. Q245. Examine the reasons for groundwater stress and ways through which India can harness floodwaters as a strategy to alleviate water stress. 15 marks, 250 words, core demand of question. Brief about the reasons behind growing water stress in India. Suggest ways in which India can harness floodwaters as a strategy to alleviate water stress. ANS. According to the World Resources Institute, WRI, a country facing extreme water stress means it is using at least 80% of its available supply. High water stress means it is withdrawing 40% of its available supply. As per Composite Water Management Index by NITI Aayog, more than 600 million people facing acute water shortages in India. Floodwaters, often seen as a destructive force, can be harnessed as a valuable resource to alleviate water stress in India. Reasons behind growing water stress in India. Uneven distribution. Water resources are unevenly distributed, leading to regional disparities in water availability, such as in arid Rajasthan and water-rich states like Assam. Interstate water disputes. Some of the prominent examples are the Kaveri dispute between Karnataka and Tamil Nadu, the Krishna dispute between Maharashtra, Karnataka and Andhra Pradesh, and the Mahanadi dispute between Odisha and Chhattisgarh. Pollution of rivers. Pollution from industrial discharge and untreated sewage contaminates surface water sources, rendering them unusable. For example, the Yamuna River in Delhi is considered one of the most polluted rivers in the world. Industrial expansion. The industrial sector's growing water needs, often accompanied by pollution, strain water resources. For example, the Ganga River receives billions liters of sewage and industrial waste every day. Poor water management. Inefficient water distribution systems and inadequate infrastructure contribute to water stress. India also loses about 40% of its treated water due to leakages and thefts in urban areas. Unsustainable agricultural practices. Farmers cultivate water-intensive crops like paddy and sugarcane in rain-deficit states like Punjab and Maharashtra, respectively. These crops account for about 24% of India's total irrigated area, but consume about 60% of its irrigation water. Urbanization. Rapid urbanization has led to increased water consumption, pollution of water bodies, and reduced groundwater recharge. For example, Chennai lost 33% of its wetlands in last one decade, contributing to its severe water crisis in 2019. Population growth. As per the UN estimate, India's population will surpass 1.5 billion people by the end of this decade. Also, NITI Aayog report, India's water demand is projected to be twice the available supply by 2030. Ways to harness floodwaters to alleviate water stress. Floating solar farms. India should emulate the success of the largest floating solar plant in Kerala's Banasura Sagar Reservoir. This innovative approach not only generates clean energy, but also addresses water scarcity by reducing evaporation from the water surface. Smart irrigation. Taking inspiration from the Karnataka government's Krishi Bhagya program, India can adopt sensor-based irrigation systems. They use real-time data to precisely deliver water to crops, ensuring optimal utilization and minimizing wastage. Underground reservoirs. By creating vast underground storage capacity, excess floodwater can be safely retained, preventing evaporation and contamination. These reservoirs become invaluable during periods of water scarcity. Leveraging technology. Israel's WaterGen technology serves as a prime example of innovation in water sourcing. India can explore similar technologies that extract clean drinking water from the air, using floodwaters as a source. Green roofs. Chennai's initiatives in promoting green roofs can be scaled up. Green roofs not only absorb rainwater, but also act as natural coolants, reducing energy consumption in buildings. Flood-tolerant livestock. Flood-resistant livestock breeds, like India's Gur cow, play a crucial role in ensuring food security during waterlogged conditions. Encouraging the breeding and adoption of such resilient breeds can safeguard rural livelihoods and food supplies. Artificial intelligence for flood control. Learning from the Netherlands, India can implement AI-driven flood control systems. These systems use real-time data to manage water levels, preventing flooding and optimizing floodwater utilization. Aquifer recharge credits. A system similar to California's groundwater recharge credits can be developed. Entities earn credits for replenishing aquifers during floods, which can be redeemed during droughts, ensuring long-term groundwater sustainability. Floodwater filtration gardens. Inspired by the Netherlands' water squares, India can create floodwater retention areas with natural filtration systems. These gardens enhance water quality by removing pollutants, promoting healthier ecosystems. Incorporating strategic floodwater management practices can serve as a powerful tool to combat water stress in India. Harnessing floodwaters offers a sustainable and innovative solution that not only helps in managing floods, but also ensures the efficient use of a valuable resource, contributing to the nation's water security and resilience against climate change impacts. Q246. Outline the critical characteristics of mangroves. Additionally, delve into the factors contributing to their degradation in the present times. 15 marks, 250 words, core demand of question. Shed light upon the critical characteristics of mangroves. Discuss the factors that contribute to the degradation of mangroves in the present times. Provide a suitable way forward in this regard. ANS. Mangroves are coastal ecosystems and represent a type of intertidal forest characterized by salt-tolerant trees, shrubs, and other vegetation that grow in the transition zone between land and sea. Across the world, there are over 50 recognized species of mangroves. Some well-known mangrove species include the red mangrove, Rhizophora, black mangrove Avicennia, and white mangrove Laguncularia. Critical characteristics of mangroves. Salt tolerance. Mangroves thrive in saline or brackish water environments by filtering salt from seawater, either excreting it through specialized salt glands or retaining it in salt-absorbing cells. For example, red mangroves thrive in areas with soil salinities ranging from 60 to 65 ppt, whereas black and white mangroves are typically located in soils with salinities exceeding 90 ppt. Intertidal habitat. Mangroves grow in the intertidal zone, where they are regularly inundated by tidal waters and exposed during low tide. Root systems. Mangrove trees, like Rhizophora mucronata, often have extensive root systems, including stilt roots and prop roots, which help stabilize the trees in soft, muddy soils and allow for oxygen uptake during tidal inundation. Biodiversity. These ecosystems support a rich diversity of plant and animal species, serving as important nurseries for marine life. For example, wild prawns caught off Australia's Northern Territories and Queensland rely on mangroves for growth and constitute one of the country's most valuable fisheries, earning almost $72 million a year. Coastal protection. Mangroves act as natural barriers against erosion, storm surges, and tsunamis by dissipating wave energy and thus stabilize shorelines. For example, during the 2004 Indian Ocean tsunami, Wallah, shielded by 200 hectares of healthy mangroves, had only 2 tsunami-related fatalities. In contrast, Wandaruppa, with degraded mangroves, for example, saw 5,000 to 6,000 deaths in the district. Water quality. Mangroves improve water quality by trapping sediments and filtering pollutants from runoff before they reach the sea. For example, mangrove forests can enhance water quality by raising dissolved oxygen levels by 32.39% and lowering phosphate, ammonia, and nitrate levels by 88.23%, 73.77%, and 64.28%, respectively. Carbon sequestration. Mangroves sequester carbon from the atmosphere and store it in their biomass and accumulated sediments, thereby contributing to the mitigation of climate change. As an illustration, each mangrove tree planted by Eden Reforestation Projects has the capacity to sequester over 308 kilograms of CO2 from the atmosphere over the course of its lifetime. Factors contributing to the degradation of mangroves in the present times. Deforestation. The conversion of mangrove areas for agriculture, urban development, and aquaculture has led to widespread deforestation, resulting in the loss of mangrove habitats. To illustrate, about 1/5 of mangroves worldwide have disappeared since 1980, primarily due to clearance for agriculture, often resulting in contamination from waste, antibiotics, and fertilizers. Pollution. The discharge of industrial, agricultural, and domestic pollutants, including oil spills, chemicals, and plastic waste, poses a significant threat to mangroves and the dependent wildlife. For example, India has lost around 40% of its mangrove cover in the last century, primarily attributed to urbanization, pollution, and unsustainable activities. Climate change. Mangrove ecosystems are increasingly vulnerable due to rising sea levels, elevated temperatures, and more frequent extreme weather events associated with climate change. For example, climate change-induced sea level rise is projected to result in the total destruction of coastal mangroves in Mexico and an 85% loss in the Philippines. Tourism. Unregulated tourism and recreational activities in mangrove areas are contributing to habitat destruction, pollution, and disturbances to wildlife. For example, in 1994, tourism-driven development on Union Island in the Caribbean led to the destruction of an ancient mangrove forest. Unsustainable fishing practices. Overfishing and the use of destructive fishing methods within mangrove areas deplete fish stocks and harm the overall health of mangrove ecosystems, as observed in the mangroves of Southeast Asia. Way forward. Promote conservation initiatives. Implement comprehensive conservation measures, such as designating protected areas and enforcing anti-deforestation regulations. For example, India's Mishti scheme. Sustainable practices. Encourage sustainable practices in agriculture, aquaculture, and fishing to reduce the pressure on mangrove ecosystems. For example, the sufficiency economy philosophy of Thailand serves as a model. Climate resilience. Invest in climate-resilient mangrove restoration and adaptation efforts, including mangrove planting projects in vulnerable areas. Tourism regulations. Establish and enforce regulations for sustainable tourism and recreational activities in mangrove areas to minimize environmental impact, akin to coastal regulation zones, CRZ, in India. Pollution control. Implement stricter pollution control measures and waste management practices to reduce contamination in mangrove environments. For example, Sri Lanka's successful efforts in this regard serve as a valuable inspiration for preserving its mangroves. Community involvement. Engage local communities in mangrove conservation efforts, fostering awareness and local stewardship of these critical ecosystems. For example, the community-based ecological mangrove rehabilitation, KBEMR, project in Indonesia serves as an inspiring example. Despite being vital components of coastal ecosystems, mangroves are confronted with numerous threats in the present day. Ensuring the preservation of these invaluable coastal environments for future generations necessitates the implementation of unified conservation initiatives, the adoption of sustainable practices, and the elevation of awareness regarding their significance. Q247. Elaborate on the concept of the South Atlantic anomaly. Additionally, shed light on the potential multidimensional consequences of this phenomenon. 10 marks, 150 words, core demand of question. Provide the key characteristics of this phenomenon. Discuss the potential multidimensional consequences of this phenomenon. ANS. The South Atlantic anomaly, SAA, is an area in the South Atlantic scene where Earth's magnetic field is weaker than it is at other locations on the planet's surface. To exemplify the variation in the SAA, one can envision Earth's magnetism as emanating from a compact yet potent bar magnet. In this scenario, The SAA can be likened to shifting this magnet slightly northward from the equator's plane, oriented more or less toward the direction of Singapore. Key characteristics of the South Atlantic anomaly. Origin. The SAA originates from Earth's core due to two main factors: the tilt of its magnetic axis and the movement of molten metals within the outer core. Tilt of magnetic axis. Earth's magnetic field is generated by the movement of molten iron and nickel in its outer core. However, this flow is not perfectly aligned with the planet's rotational axis. Instead, it is slightly tilted. This tilt in the magnetic axis contributes to the emergence of the SAA. Flow of molten metals. Within Earth's outer core, molten metals, particularly iron and nickel, circulate in complex patterns. These movements generate the planet's magnetic field. Irregularities and disturbances in the flow of these molten materials within the outer core play a crucial role in the formation of the SAA. Weakened magnetic field. In the SAA, there is a significant reduction in the strength of Earth's magnetic field. This weakening results from disruptions and irregularities in the flow of molten material deep within the core. Over the last 2 centuries, Earth's magnetic field has experienced a loss of approximately 9% of its strength. Dip in magnetic intensity. The SAA is marked by a noticeable dip in the intensity of the magnetic field compared to the surrounding areas. This indicates that the magnetic field lines are less concentrated and less tightly packed in this region. Scientists have observed the intensified weakening of magnetic fields in the southwest of Africa. Location shift. The exact position of the anomaly is not fixed but undergoes shifts over time. These shifts are influenced by the dynamic processes occurring within Earth's core and mantle. Size variation. The size of the SAA is not constant and can change, either expanding or contracting over different time periods. These fluctuations reflect the dynamic nature of the magnetic disturbances within the region. Splitting. The SAA may undergo a process of splitting, potentially resulting in the formation of 2 separate low points within the anomaly. Recent developments in the eastern minimum of the South Atlantic anomaly suggest the possibility of it splitting into 2 separate low points. Potential multidimensional consequences of South Atlantic anomaly. Navigation and communication. Weakened magnetic fields within the SAA can affect navigation systems and communication technologies reliant on accurate compass readings and satellite signals. Distortions in magnetic data can lead to errors in navigation, which is particularly critical for aircraft and spacecraft. Satellite operations. Low Earth orbit satellites passing through the SAA may experience technical issues due to the altered magnetic field. These anomalies can affect satellite operations, including data transmission, weather forecasting, and Earth monitoring. To illustrate, SAA can induce short circuits and malfunctions in onboard technological systems when bombarded by high-energy protons from the Sun. Radiation exposure. The SAA intensifies the entry of charged particles like protons and electrons into Earth's atmosphere, posing risks to high-altitude travelers and spacecraft operations. Technological disruptions. NASA has reported instances of modern laptops crashing when space shuttle flights passed through the anomaly, indicating the potential for technological disruptions during missions in this region. Pole reversal. Speculation surrounds the SAA as a potential indicator of an impending pole reversal, a relatively common event occurring approximately every 250,000 years, with the last reversal taking place 7.8 lakh years ago. Scientific research. The South Atlantic Anomaly, SAA, while presenting challenges, serves as a distinctive window for scientific exploration, offering valuable insights into Earth's core dynamics and magnetic field behavior. The Swarm Constellation mission of the European Space Agency, ESA, exemplifies this. The South Atlantic Anomaly, SAA, stands as a unique and continually evolving aspect of Earth's magnetic field. Its presence serves as a poignant reminder of our planet's perplexed and dynamic nature, encouraging us to delve deeper into the mysteries of the natural world while safeguarding the resilience of our technological pursuits. Q248. What is a climate tipping point, and why is it considered a critical concern in the context of climate change? 10 marks, 150 words, core demand of question change. Provide a suitable way ahead in this regard. Explain why the climate tipping point is considered a critical concern in the context of climate ANS. A climate tipping point refers to a critical threshold in the Earth's climate system beyond which a relatively small change in external conditions can lead to a significant and often irreversible change in the state of the system. Researchers have identified 9 global core tipping elements and 7 regional impact tipping elements. A few examples of climate tipping points include the Amazon rainforest, Arctic sea ice, and the boreal forest. Climate tipping point. A critical concern in the context of climate change over the past century, Earth's temperature has risen by about 2 degrees Fahrenheit, primarily increasing at 0.14 degrees Fahrenheit per decade since 1880, but accelerating to 0.32 degrees Fahrenheit per decade since 1981. In this scenario of climate change, the crossing of climate tipping points has become a critical concern for the following reasons. Irreversible changes. Once a tipping point is crossed, the changes it triggers can be irreversible on human timescales. This means that even if we reduce greenhouse gas emissions and mitigate other factors contributing to climate change, we may not be able to undo the damage caused by a tipping point. For example, disintegration of the West Antarctic ice sheet. Unpredictable outcomes. Tipping points are often associated with nonlinear and abrupt changes in climate systems. Predicting when and how they will occur can be challenging, making it difficult to prepare for or adapt to their consequences. For example, this complexity can be observed in the Dansgaard-Oeschger events during the last ice age, with 25 sudden climate fluctuations over 500 years. Cascading effects. Tipping points in one part of the climate system can trigger cascading effects, leading to the activation of other tipping points in different regions or systems. This interconnectedness can amplify the overall impact of climate change. For example, the potential shutdown of the AMOC could cascade to affect the Amazon rainforest, monsoon systems, and the West Antarctica and Greenland ice sheets. Ecosystem disruption. Tipping points can disrupt ecosystems, leading to species extinction, shifts in habitat ranges, and altered biodiversity. At the current warming level, we face the potential for both tropical coral reef death and abrupt permafrost thaw. Human impacts, climate tipping. Points can directly affect human populations through extreme weather events, sea level rise, and altered agricultural patterns. These impacts can also lead to displacement, resource scarcity, and conflict. According to Oxfam, climate change is the main cause of internal displacement, with a 5-fold rise in those displaced by extreme weather events in the past decade. As climate change continues and tipping points are crossed, this crisis will worsen due to rising sea levels from climate-induced changes. Feedback loops. Many climate tipping points are associated with feedback loops, where a small change in one factor can lead to self-reinforcing processes that accelerate warming, amplifying the severity of climate change. For example, the melt elevation feedback in the Greenland ice sheet serves as an illustration. Climate tipping points signify pivotal thresholds in our planet's climate system. In the face of severe climate change, there is a heightened risk of surpassing these critical points. Nevertheless, through diligent mitigation and adaptive measures, we can steer away from the precipice of tipping points and cultivate a sustainable world where both the natural world and human society can flourish. Extra edge. Humanity's contribution to a 1.1 degrees Celsius global temperature increase may have already pushed us past 5 perilous tipping points. Moreover, 4 of these tipping points become increasingly likely as global warming surpasses 1.5 degrees Celsius. Q241. How does deforestation contribute to increased vulnerability to flash floods in hilly regions of India? 10 marks, 150 words. Core demand of question of India. Show how deforestation contributes to the increase in vulnerability to flash floods in hilly regions. Answer. India's exposure to floods encompasses over 40 million hectares of its 329 million hectares landscape, marked by heightened vulnerability, NDMA. This susceptibility is notably accentuated in hilly regions, where flash floods, sudden and intense deluges as seen recently in Himachal Pradesh, intensified due to various catalysts. Prominent factors include altered river courses, increased urbanization, and climate change impacts. However, out of these, deforestation looms large as a pivotal contributor, amplifying the risk substantially as explained below. Deforestation and increased vulnerability to flash floods in hilly regions of India. Reduced vegetation cover. Eliminating trees and plants reduces natural cover that absorbs and slows rainwater. For example, evident in the Western Ghats. This impact was stark during the 2018 Kerala floods, where deforested areas experienced exacerbated flooding due to diminished vegetation. Surface runoff. Without trees and plants to intercept rainwater, there's increased surface runoff, causing water to flow rapidly downhill, leading to higher flash flood potential, for example. 2010 flash floods in Ladakh. Loss of root systems. Tree roots, pivotal in soil cohesion, lose their presence through deforestation, thus compromising soil structure and rendering it prone to erosion. For example, 2009 Nilgiris flash floods. Landslides. Deforested slopes are more prone to landslides during heavy rainfall, especially in hilly regions. For example, 2013 Uttarakhand floods. Deforestation played a role in triggering landslides that worsened the disaster. Reduced water infiltration. Trees enhance water infiltration into the soil. Deforestation decreases this capacity, leading to less water being stored underground and more water running off quickly. For example, the 2000 flash flood along the Sankoshi River in Darjeeling, West Bengal. Flash flood peak intensity. Deforested areas experience higher peak intensities during flash floods as water rushes downhill more swiftly. For example, the flash floods in Shimla in 2015 were characterized by high peak intensity due to deforestation in surrounding areas. Riverbank erosion. The absence of vegetation along riverbanks caused by deforestation contributes to bank erosion and alters river courses, increasing flood vulnerability. For example, the 2017 floods in the Teesta River of Sikkim. Soil erosion. The stabilizing influence of trees and plants on soil is disrupted by deforestation, leading to escalated soil erosion that results in sediment accumulation in rivers and streams, intensifying flood hazards. Increased sedimentation. Deforestation results in increased sediment flow into rivers. Sedimentation can clog waterways, potentially causing floods. For example, the 2013 floods in the Ganges-Brahmaputra-Meghna basin were worsened by sedimentation caused by deforestation. Altered microclimates. Deforestation disrupts rainfall patterns, sometimes leading to intense, sudden downpours that trigger flash floods. For example, the 2014 and 2021 flash floods in Kashmir and the Garhwal region, respectively. Loss of buffer zones. Forests, acting as natural buffers by impeding and absorbing surplus rainfall, serve as protective areas. For example, their removal, as seen in the 2005 Agum, Karnataka flash floods, exacerbates the intensity of such disasters. Disrupted hydrological cycle. Deforestation disrupts the natural water cycle, affecting water storage, evaporation, and precipitation patterns, which can lead to unpredictable flash floods. For example, the Malabar Hill flash flood in Mumbai during 2005 provides an instance of how deforestation disrupts the hydrological cycle. Amidst the complicated tapestry of nature, deforestation significantly amplifies the susceptibility of flash floods in Indian hill regions. The journey ahead calls for collective action, policy reinforcement, and a harmonious coexistence with the environment. This restorative symphony envisions a future where deforestation yields to sustainable coexistence, diminishing flash flood vulnerability. Extra edge. Strategies to deal with the problem. Agroforestry empowerment. Implementing incentive-linked agroforestry, such as providing farmers with training and rewards for cultivating trees alongside crops, enhances diversified land use, stabilizes soil, and reduces surface runoff, consequently diminishing vulnerability to flash floods. Community forest guardianship. Through collaborative reforestation stewardship, where local communities form forest management groups to plant native trees and ensure sustainable forest practices, resilience against flash floods is fortified while fostering a sense of community ownership. Satellite vigilance. Establishing a satellite sentinel network that utilizes real-time data interpretation tools to monitor deforestation patterns enables prompt identification of vulnerable areas and swift responses to activities like illegal logging, ultimately mitigating flash flood risk. Forecast-driven alerts. By integrating indigenous knowledge with advanced early warning systems that employ factors like rainfall data and soil moisture levels to predict flash floods, communities receive culturally relevant and timely alerts, minimizing casualties and damage. Sustainable urban landscaping. Integrating resilient urban greenbelt systems, including permeable pavements, retention ponds, and vegetated buffers, into urban planning effectively absorbs excessive rainfall, curbing runoff, and mitigating downstream flood risk. Awareness through digital outreach. Executing multimedia ecological education campaigns, such as using local radio broadcasts and mobile applications to disseminate information on deforestations linked to flash floods, fosters awareness, promoting sustainable land management and disaster preparedness. Q250. Examine the threats imposed upon coral reefs by climate change, substantiating your analysis with illustrative examples. 15M Core Demand of Question. Discuss the threats imposed upon coral reefs by climate change. Provide relevant examples to substantiate your analysis. Suggest some strategies to deal with these threats. ANS. Coral reefs are intricate underwater ecosystems formed by the calcium carbonate skeletons of coral polyps, supporting diverse marine life and often found in warm, clear tropical waters. Examples of coral reefs include the Great Barrier Reef, Rainbow Reef in Fiji, and the Red Sea coral reefs. However, these underwater ecosystems, often referred to as the rainforests of the ocean, are currently facing their greatest global threat due to climate change. Threats imposed upon coral reefs by climate change. Ocean warming. Rising sea temperatures, driven by climate change, lead to coral bleaching. Corals rely on symbiotic algae, zooxanthellae, for nutrients and vibrant colors. High sea temperatures cause corals to expel these algae, resulting in bleaching, weakening corals, and increasing susceptibility to diseases. For example, in 2016 and 2017, the Great Barrier Reef in Australia experienced back-to-back bleaching events due to unusual sea temperatures, affecting 2/3 of the reef and leading to extensive coral mortality. Ocean acidification. Climate change is resulting in ocean acidification, making it more challenging for corals to construct and uphold their structures. For example, this is underscored by a recent study revealing a substantial 14% decline in coral growth within the Great Barrier Reef since 1990, marking the most significant decline in 4 centuries. Sea level rise. Due to climate change, rising sea levels pose a threat to these vital ecosystems, leading to increased submergence and sedimentation. This situation reflects historical evidence suggesting that coral reefs may have drowned during the last deglaciation due to adverse environmental conditions associated with sea level rise. For example, global mean sea level has risen by 21 to 24 centimeters since 1880, according to a report by the National Oceanic and Atmospheric Administration, NOAA. Extreme weather events and altered weather patterns. Climate change brings about extreme weather events like hurricanes and cyclones, which can physically damage coral reefs by breaking or overturning corals. Additionally, shifts in weather patterns can influence rainfall timing and intensity, causing excess freshwater runoff from heavy rains to introduce pollutants, sediments, and nutrients into coastal waters. This poor water quality can further harm coral reefs. To exemplify, the Indian Ocean's Chagos archipelago has seen shifts in weather patterns, leading to an increase in coral bleaching events. For example, the hurricanes Irma and Maria in 2017 caused extensive damage to coral communities in the Caribbean. Altered ocean currents. Climate change can disrupt ocean currents, potentially affecting the distribution of coral larvae. For example, the Red Sea has experienced alterations in its circulation patterns, affecting the transportation of nutrients and larvae, which can impact the health and diversity of its coral reefs. Disease outbreaks. Elevated sea temperatures and stress weaken coral colonies, rendering them more vulnerable to diseases. For example, in the Dampier Strait MPA, various coral diseases, including WS, BRBD, FB, ADN, bleaching, and tumor, have been identified, illustrating the multifaceted challenges corals face. Reduced coral resilience. Multiple stressors resulting from climate change can reduce the overall resilience of coral reefs. For example, the Hawaiian Islands have faced a combination of threats, including bleaching, ocean acidification, and increased storms, reducing the overall resilience of its coral reefs. Strategies to deal with the threats. Coral nurseries. Establish coral nurseries to propagate and grow resilient coral species, as demonstrated by the Coral Restoration Foundation's successful efforts in the Florida Keys. Coral bleaching forecasting. Implement real-time monitoring systems like Australia's Great Barrier Reef Marine Park Authority's Coral Bleaching Early Warning System to predict coral bleaching events and enable timely protective measures. Marine Protected Areas, MPAs expand and effectively manage MPAs around coral reefs, with proper enforcement of no-take zones, as seen in the success of the Chagos Marine Protected Area in the Indian Ocean. Coral Reef Insurance. Explore innovative financial mechanisms like coral reef insurance, as demonstrated by the Nature Conservancy, TNC, and its partners who successfully pioneered the world's first reef insurance policy designed to mitigate the significant risk of hurricane damage to coral reefs. Cool roofs and reflective pavements. Implement urban planning strategies like the Cool Roofs program in New York City to reduce heat absorption in coastal areas, helping mitigate the urban heat island effect and reducing stress on nearby reefs. Global emission reduction. Implement and enforce international agreements and policies, such as the Paris Agreement, to significantly reduce greenhouse gas emissions, thereby mitigating ocean warming and acidification. The severity and complexity of climate change threats to coral reefs are undeniable. Through the implementation of effective strategies and heightened awareness of their pivotal role in marine ecosystems and coastal communities, we can strive for a future where these vibrant underwater landscapes not only endure but flourish in spite of climate challenges. Q241. Discuss the concept of the resource curse and its ramifications on nations which are abundant in natural resources. 10 marks, 150 words, core demand of question. Delve into the ramifications of resource curse for nations abundant in natural resources. Substantiate with the relevant examples. ANS. The resource curse, also known as the paradox of plenty or Dutch disease, refers to a phenomenon where countries rich in valuable natural resources, such as minerals, oil, or gas, experience negative economic and social consequences despite their apparent wealth. This counterintuitive situation often leads to underdevelopment, economic instability, and governance challenges. For example, resource-rich countries with relatively poor rates of economic growth include Nigeria, Zambia, Sierra Leone. Ramifications of resource curse for nations abundant in natural resources. Economic instability. Resource-dependent economies are vulnerable to fluctuations in commodity prices. For example, oil-exporting countries like Venezuela experienced economic downturns due to oil price declines, leading to budget deficits and reduced public services. Diversification neglect. Over-reliance on a single resource can hinder economic diversification. For example, in Angola, heavy dependence on oil exports hampered development in other sectors, leaving the economy vulnerable to oil price shocks. Weak governance. Resource wealth can foster corruption and weaken governance structures. For example, in Nigeria, mismanagement of oil revenues and corruption have hindered development and impeded poverty reduction. Inequality. Resource wealth can exacerbate inequality by concentrating wealth among a few elites. In Equatorial Guinea, oil revenues have not translated into improvements for the majority of the population. For example, the number of people in Equatorial Guinea who are earning less than $2.15 per day is forecast to amount to 0.4 million in 2023. The total population of the country is 1.6 million. Political instability. Countries with valuable resources may experience conflict over control and distribution of resource revenues. For example, in the Democratic Republic of Congo, conflict over mineral resources has fueled instability for years. Environmental degradation. Resource extraction can lead to environmental damage. In the Amazon rainforest, mining for gold and other minerals has caused deforestation and pollution, impacting biodiversity and local communities. Currency appreciation and competitiveness loss. Resource exports can lead to currency appreciation, affecting non-resource industries. For example, in Australia, the mining boom led to a strong Australian dollar, impacting sectors like manufacturing. Limited human capital development. Resource revenue can lead to neglect of investments in education and healthcare. For example, in Sudan, oil revenue did not contribute to sufficient human capital development, impacting long-term growth. Sudan's HDI value is 0.508. Acknowledging the detrimental impact of the resource curse, which hinders nations despite their resource abundance, it becomes evident that efficiently administering and equitably distributing resources for sustainable development is a complex challenge that demands innovative solutions. Through concerted efforts, nations can navigate resource-related difficulties more effectively and work towards achieving sustainable development goals. Q252. What is your comprehension of the beast from the East, and why does it raise apprehensions in the contemporary scenario? 10 marks, 150 words, core demand of question. Discuss the causes of this phenomenon. Highlight the key features of this event. Describe the apprehensions related with this phenomenon in the contemporary scenario. ANS. In February 2018, the United Kingdom and Ireland experienced a meteorological phenomenon known as the Beast from the East, causing widespread disruption due to a cold and wintry weather system. Subsequently, Beast from the East became a term used to describe prominent weather events observed in Europe, especially in the United Kingdom, during late winter or early spring. Causes of Beast from the East. Polar jet stream shift. The Beast from the East is caused by a change in the position of the northern polar jet stream, a high-altitude wind that influences weather patterns. During this phenomenon, the jet stream shifts southwards, allowing cold air from the Arctic region to flow into Europe. Siberian high-pressure system. The arrival of the Beast from the East is often associated with the establishment of a Siberian high-pressure system over the continent of Asia. This high-pressure system brings cold and dry air from Siberia into Europe, leading to cold temperatures and wintry conditions. Easterly winds. The combination of the polar jet stream shift and the Siberian high-pressure system results in the prevalence of easterly winds over the United Kingdom and Ireland. These winds blow from the east and bring extremely cold air from Russia and northern Europe. Cold continental air mass. The Beast from the East is characterized by the influx of a cold continental air mass into the region. This air mass originates from the icy plains of Siberia, where temperatures can be extremely low during the winter months. Interaction with moisture. While the cold air from the east dominates the Beast from the East, it can interact with moisture from the North Sea and the Atlantic Ocean. This interaction can lead to the development of snow showers and heavy snowfall, particularly in eastern coastal areas. Temperature inversions. During the Beast from the East, temperature inversions can occur, wherein cold air near the surface is trapped under a layer of warmer air atop. This stable atmospheric condition can enhance the persistence of cold temperatures and increase the potential for snow accumulation. ENSO, El Niño Southern Oscillation, and NAO, North Atlantic Oscillation. Both ENSO and NAO are large-scale climate patterns that directly influence the positioning of the polar jet stream, which, in turn, can impact the occurrence and intensity of cold spells like the Beast from the East in Europe. While ENSO affects global weather patterns, NAO specifically influences the positioning of the jet stream in the North Atlantic, leading to shifts in the transport of cold air masses into Europe. Polar vortex. The polar vortex, formed by temperature differences between polar and mid-latitudes, usually keeps cold air in the polar regions. When it weakens, parts can move southwards, bringing extremely cold temperatures to America and Europe. This clash with warmer Atlantic air causes the Beast from the East, with intense snowstorms and freezing temperatures. Key features. Intense cold wave. The Beast from the East is characterized by the arrival of an intense cold wave originating from Eastern Europe or Siberia. Late winter or early spring occurrence. This meteorological event typically occurs during late winter or early spring, impacting regions in Europe, notably the United Kingdom. Extreme cold temperatures. The weather phenomenon brings exceptionally low temperatures, resulting in freezing conditions across affected areas. Significant snowfall. Alongside the cold wave, there is substantial snowfall, leading to snow accumulation and potential disruptions in transportation and daily activities. Strong winds. The cold wave is often accompanied by strong and gusty winds, exacerbating the severe weather conditions and creating wind chill effects. Impact on daily life. The Beast from the East can cause various disruptions, including delays in transportation, school closures, and potential hazards to public safety due to the extreme weather elements. Apprehensions. Increased frequency of extreme weather events. After this event, the UK witnessed an increased frequency of extreme weather events, including heat waves in 2019 and floods in 2020. Warming Arctic and weakening jet stream. The Arctic is warming at twice the global average rate, and this rapid warming can disturb the polar jet stream. According to a study, the weakened and more wavy jet stream was linked to severe cold outbreaks and prolonged weather patterns like the beast from the east in Europe. Increased variability. Beast from the east is leading to increased variability in weather patterns, making extreme events more unpredictable. WMO reported that climate variability and extreme weather events have surged in the 21st century, with temperature, precipitation, and wind patterns becoming more erratic. Impacts on vulnerable populations. Extreme cold events pose risks to vulnerable populations, including the elderly, children, and those experiencing homelessness. During the Beast from the East in 2018, the UK's National Health Service, NHS, reported a surge in weather-related injuries and illnesses, including hypothermia and cold-related accidents. Impact on agriculture. The Beast from the East impacts agriculture by damaging crops and livestock, leading to losses for farmers and disrupting food production. This disruption can result in higher food prices, affecting the agricultural sector and consumers. The Beast from the East caused an estimated £161 million in losses to the agricultural industry. Economic and social disruptions. Severe cold snaps can result in significant economic losses due to disrupted transportation, business closures, and increased energy demand. According to the London School of Economics, the Beast from the East in 2018 cost the UK economy an estimated £1 billion per day during the height of the disruption. Interactions with other climate phenomena. The Beast from the East may interact with other climate phenomena, leading to more complex weather patterns. For instance, interactions with the North Atlantic Oscillation, NAO, can influence the severity and duration of cold spells, as observed during the 2018 event. Impact on preparedness. The Beast from the East showed that we are not adequately prepared for extreme weather events. The government and businesses need to do more to prepare for these events, such as stockpiling resources and developing contingency plans. The Beast from the East reminds us of Earth's climate vulnerabilities, but also offers an opportunity for positive action. Understanding its causes can lead to innovative climate solutions like embracing renewables, enhancing weather preparedness, and implementing sustainable practices for a resilient future. Let it be a catalyst for positive change as we protect our planet and create a climate-safe world. Extra Edge. According to the Intergovernmental Panel on Climate Change, IPCC, the frequency of cold waves in Europe has decreased significantly over the past century, but cold extremes, like the Beast from the East, are still possible due to atmospheric circulation changes induced by global warming. The Beast from the East caused power outages for over 1 million people in the UK. The UK Health Security Agency reported that there were 17,000 more hospital admissions for respiratory illnesses in the week following the Beast from the East. The Visit Britain Tourism Agency estimated that the Beast from the East cost the UK tourism industry £300 million in lost revenue. The National Grid reported that energy demand was 10% higher than normal during the Beast from the East. A study by the Met Office found that the probability of a cold snap like the Beast from the East has increased by 50% since the 1960s. The UK government has since developed a new national risk register, which identifies the most significant risks facing the country, including extreme weather events. Q241toQ263. Discuss the tourism potential of Northeast India. Additionally, provides insights into the geographical challenges that hinder the full realization of this potential. 10 marks, 150 words, core demand of question. Brief about the tourism potential of Northeast India. Mention about the geographical challenges that hinder the full realization of this potential. ANS. Every state in the Northeast is endowed with breathtaking scenery and unique historical, cultural, and ethnic backgrounds. With all of this, the region's tourist potential is enormous. Northeast India, with its vast natural resources, snow-capped Himalayas, tropical forests, and rich traditional values, is a paradise unexplored. But this scenario is changing gradually. E.g., the number of domestic tourist arrivals to the region has increased from 3.13 million in 2003 to 11.84 million in 2022. Tourism potential of Northeast India. Ecotourism. Northeast region is a hub of nature and ecotourism with breathtaking natural landscapes, lush green valleys, majestic mountains, huge waterfalls, river islands, national parks, etc. For example, Malinong village in Meghalaya with cozily built houses amidst exotic flowers is an example of ecotourism. Wildlife tourism. The region's national parks, wildlife sanctuaries and forest reserves are home to majestic mammals, colorful birds, and elusive reptiles. They offer visitors a chance to explore the region's rich biodiversity and unique ecosystems. For example, Debru-Saikhowa National Park in Assam is home to rare and endangered species such as the white-winged wood duck, water buffalo, and Gangetic dolphin. Cultural diversity. Northeast Indian states offer a mixed culture of Hinduism, Christianity, Islam, and Buddhism, and have a large number of ethnic groups with their own unique tribal culture, folk dances, food, and crafts. For example, the festivals of the region like Bihu of Assam, Hornbill of Nagaland, Songai of Manipur, Karchi Puja of Tripura, Torgya in Arunachal Pradesh, and Shillong Autumn Festival of Meghalaya have become cultural brands of the region. Adventure tourism. Northeast India with its long range of mountains and hills, deep valleys, wildlife parks, and inland rivers offer a variety of adventure activities like trekking, camping, wildlife safaris, rock climbing, jeep safaris, water rafting, boat safaris, and hot air ballooning. For example, trekking in the Dzukku Valley of Nagaland and river rafting in Arunachal Pradesh's Shang River. Religious and spiritual tourism. Northeast India is a home of diverse religions like Hinduism, Buddhism, Christianity, and Islam. So the region hosts a diverse array of religious sites, pilgrimage destinations, and spiritual centers, each offering unique experiences and opportunities for reflection and worship. For example, Tawang Monastery in Arunachal Pradesh, Kamakya Temple in Assam. Tea tourism. Northeast India is known for some of the finest and most sought-after varieties of tea in the world, including Assam tea, Darjeeling tea, and Nilgirai tea. Tea tourism refers to visitors immersing themselves in the rich history, culture, and intricacies of tea cultivation by means of guided tours. For example, tea tasting sessions organized at Makabari Tea Estate, located in the Darjeeling district of West Bengal. Geographical challenges that hinder the full realization of tourism potential. Terrain and connectivity. Northeast region with its rugged terrain, dense forests, steep slopes, and winding rivers makes it difficult to construct transport infrastructure. Many areas in the region are yet to be connected with the rest of the country. For example, Sikkim has yet to get its first train service by means of the Sivak Rangpa Rail project. Natural disasters. Natural disasters like floods, landslides, and earthquakes, particularly during the monsoon season, damage the infrastructure. This disrupts travel plans and poses safety risks for tourists. For example, Majalai Island in Assam is prone to flooding during the monsoon season, hindering its tourism potential. Variability in climate. Northeast India experiences diverse climatic conditions, ranging from tropical to alpine climates. Because of this huge variability, adapting tourism strategies to suit different climates and seasonal variations becomes a humongous task. Remote and inaccessible locations. Many tourist attractions in Northeast India are located in remote and isolated areas far from major urban centers. Limited accommodation options, lack of amenities, and inadequate tourist facilities in these locations can deter visitors from venturing into lesser-known areas. For example, Tawang Monastery in Arunachal Pradesh faces accessibility challenges due to its remote location and rugged terrain. International borders. The region shares international borders with neighboring countries like China, Bhutan, Myanmar, and Bangladesh, leading to security concerns and restrictions on movement in certain areas. Political tensions and insurgent activities in some parts of Northeast India have also deterred tourists from visiting the region. For example, in Manipur, areas close to the Myanmar border face movement restrictions due to insurgent activities and cross-border smuggling, leading to increased security measures that deter tourists and affect local communities. Northeast India's potential as a rich natural, cultural, and adventurous tourism destination is somewhat underexplored compared to other parts of the country. Challenges such as limited connectivity, inaccessibility, and natural disasters require a multifaceted approach involving government agencies, local communities, and private sector stakeholders. By adequate measures, it is possible to unlock its tourism potential and help India reach new heights in the world tourism map. Q254. Assess the interrelationship between water security and food security, emphasizing their impact on agriculture and rural livelihoods. 15 marks, 250 words, core demand of question. Examine the interrelationship between water security and food security. Explain the impact of water security on agriculture and rural livelihoods. Explain the impact of food security on agriculture and rural livelihoods. ANS. Water security and food security are two interconnected concepts that are crucial for human survival as well as sustainable development. AXS per UN World Water Development Report 2023, between 2-3 billion people experience water shortages for at least 1 month per year, posing severe risks to livelihoods, notably through food security and access to electricity. Interrelationship between water security and food security. Irrigation of crops. Water security directly impacts food security by influencing the availability of water for irrigation of crops. For example, agriculture is the largest consumer of fresh water globally, accounting for around 70% of total water withdrawals. Adequate water availability ensures sufficient crop yields, whereas water scarcity leads to crop failures, exacerbating food insecurity. Livestock rearing. Water is also critical for livestock rearing and animal husbandry. Water scarcity can impair livestock health and productivity, affecting food security by reducing the availability of meat, dairy, and other animal products. Food processing. Water is also used extensively in food processing, preservation, washing and cleaning of agricultural produce, etc. Inadequate access to clean water for food processing and preparation can compromise food hygiene standards and pose risks to public health, undermining food security. Health ecosystems. Healthy aquatic ecosystems such as rivers, lakes, wetlands, and aquifers provide essential ecosystem services that support agricultural productivity and food security. Degradation of water-related ecosystems due to pollution, habitat loss, or overuse can disrupt these ecosystem services, jeopardizing agricultural livelihoods and food security. Waterborne diseases can undermine the well-being of rural communities, further exacerbating food insecurity by reducing labor productivity and increasing healthcare costs. Impact of water security on agricultural and rural livelihoods. Disruption of farming schedules. Predictable water supply is important for planning agricultural activities, such as planting and harvesting crops. Unreliable water availability due to factors like droughts, floods, etc. will disrupt farming schedules and impact farmers' livelihoods. Heavy rainfall and floods have damaged 33.9 million hectares of Indians' cropped area between 2015-16 and 2021-22 in India. Agricultural productivity. Agricultural livelihoods are dependent on water for various activities like irrigation, livestock watering, etc. Limited access to water resources due to water scarcity or competition from other users can constrain agricultural productivity. For example, in India, around 35 million hectares of cropped area was damaged between 2016-2017 to 2021-22 due to drought. Impact on poverty. Water insecurity contributes to poverty and vulnerability among agricultural communities, particularly smallholder farmers and marginalized groups. Inadequate access to water resources decreases crop productivity and undermines farmers' ability to invest in agricultural inputs, education, and health care, perpetuating cycles of poverty and deprivation. For example, poverty rate where groundwater tables have fallen below 8% has risen by 9–10%. Increased vulnerability of women. Water insecurity often impacts women disproportionately as women are often responsible for household water management responsibilities. Lack of adequate availability of water often poses a disproportionate physical and mental burden on women and limits their economic opportunities. Impact of food security on agricultural and rural livelihoods. Stability of income. The primary source of income in many rural households is agriculture. As a result of fluctuations in food production due to various factors directly impacts the farmers' incomes. For example, in India, between 2016-17 and 2020-21, farmers' income has declined 1.5% per annum because of various reasons, including fluctuation in food production. Nutritional security. Food insecurity disproportionately affects rural populations in India, particularly women and children. Poor nutrition can impact health outcomes and productivity, affecting rural livelihoods by reducing the capacity to work and earn income. For example, as per NFHS 5, around 37% of children belonging to rural areas are stunted. Social cohesion and resilience. Lack of food security can lead to social unrest, migration, suicides, and increased vulnerability to shocks and crises within rural communities. For example, as per NCRB data, around 3.58 lakh farmers have committed suicide in India from 1995 to 2019. Diversification of livelihoods. Rural livelihoods being mostly dependent on agriculture, food insecurity due to reasons like climate change, land degradation, and market fluctuations may push the farmers into non-farm activities such as small-scale enterprises, wage labor, etc. For example, as per recent data by CSDS, Delhi, 76% of current farmers want to give up farming. Addressing water security and food security challenges is critical for sustaining agriculture livelihoods. In this backdrop, integrated approaches that promote water-efficient agriculture, climate resilience, and equitable access to water and food are essential for promoting human well-being and sustainable development. Extra Edge: Strategies for Sustainable Management of Water Security and Food Security. Integrated Water Resource Management. IWRM, it is a process that promotes the coordinated development and management of water, land, and related resources in order to maximize the resultant economic and social welfare in an equitable manner without compromising the sustainability of vital ecosystems. For example, National Commission on Integrated Water Resources Development, NCIWRD, established to provide insights on management of water resources. Invest in water-saving technologies. Recent technologies like drip irrigation, micro-sprinklers, and laser leveling improve water use efficiency in agriculture and ensure water security. With drip irrigation, water use efficiency rises to 90% as opposed to only 35–40% with conventional irrigation. Policy reforms related to water. Strengthen water governance frameworks to prevent over-extraction and unsustainable use of water in agriculture, industry, and domestic sectors. For example, Atal Bhujal Yojana and National Project on Aquifer Management, NAQUIM, aims to conserve groundwater levels in India. Climate-resilient agricultural practices. Introduction of drought-tolerant crop varieties, agroforestry systems, and soil conservation measures improve water retention and mitigate the effects of water and food insecurity. For example, in East Africa, drought-tolerant maize is estimated to increase yields by 17% in severe droughts. Crop diversification. Crop diversification and mixed cropping systems enhance dietary diversity, reduce dependence on a limited number of staple crops, and improve resilience to pests, diseases, and climate variability. For example, a study published in the Journal of Food Policy showed that households practicing crop diversification had access to a wider range of food groups, leading to improved nutrition and food security outcomes. Adapt natural farming techniques. Natural farming techniques like zero-budget natural farming enable judicious use of water and at the same time increases accessibility to nutritious food. For example, zero-budget natural farming, ZBNF, methods use between 50–60% less water compared to conventional farming. Capacity building of stakeholders. Organize education, training programs, and provide extension services to farmers, water managers, and policymakers on sustainable water management practices and climate-resilient agriculture. This raises awareness among stakeholders and enables a collective action to address water and food insecurity. For example, a national workshop on Per Drop More Crop was organized by the Ministry of Agriculture and Farmers' Welfare to train farmers on micro-irrigation techniques. Q241toQ263. Analyze the role of fluvial processes in shaping landscapes and their influence on human settlements. Elaborate on the challenges faced by urban planners in managing flood hazards and ensuring ecological balance in flood-prone regions in India. 15 marks, 250 words, core demand of question. Explain the role of fluvial processes in shaping landscapes and their influence on human settlements. Mention the challenges faced in managing flood hazards and ensuring ecological balance in flood-prone regions in India. Suggest suitable way ahead in this regard. ANS. Fluvial processes involve water movement in rivers and streams that shape the earth, including erosion, transportation, and deposition of sediments. These processes create distinctive landscapes such as meanders, floodplains, and deltas. Human interactions with these systems can both affect and be affected by these evolving landscapes. Role of fluvial processes in shaping landscapes and their influence on human settlements. Transportation. Rivers transport sediments from one place to another. The Amazon River, for instance, transports large amounts of sediments from the Andes to the Atlantic Ocean. Sometimes such transportation works as scenic beauty for people. Deposition. Rivers deposit sediments when they lose energy. The creation of the fertile Mississippi River Delta demonstrates this process. As the river slows, it deposits its load, forming a delta, which in turn influences human settlement due to its fertility. Floodplain development. Floodplains are landscapes along rivers that are prone to flooding. They are highly fertile due to the nutrient-rich sediments deposited by rivers, as seen in the Nile River Valley, encouraging dense human settlement and agriculture. Formation of alluvial fans and deltas. They're formed where rivers deposit sediments as they enter a larger water body or a flatter area. The Ganges-Brahmaputra Delta is one such formation, supporting one of the world's densest human populations due to its fertile land. Influence on urban development. Many cities and civilizations have grown around rivers, utilizing them for transportation, irrigation, and as a water source. For example, cities like London, Thames, Paris, Seine, and Cairo, Nile, illustrate this dependence. Erosion. Fluvial erosion involves wearing away of the land by water bodies, primarily rivers. For example, ravines in Chambal Valley, Madhya Pradesh, were formed over millions of years through the erosion caused by the Chambal rivers and its respective tributaries. Subsequently detrimental for infrastructure development. Creation of oxbow lakes. They form when a meander of a river is cut off from the main flow. Such features can influence settlement patterns by providing habitats for diverse species and resources for fishing and irrigation. For example, lower course of Missouri River. Challenges faced in managing flood hazards and ensuring ecological balance in flood-prone regions in India. Population density. The Gangetic Plains, which houses approximately 400 million people, is prone to annual flooding. Managing flood hazards here is a major challenge due to the sheer number of people affected. Rapid urbanization. Unplanned urban expansion, as seen in cities like Chennai and Mumbai, has led to encroachment upon natural drainage systems and floodplains, exacerbating flooding and making management difficult. Deforestation. Deforestation, as seen in the catchment areas of the Brahmaputra, leads to increased runoff and sediment load in rivers, increasing the risk and magnitude of floods. Agricultural practices. Traditional agricultural practices, such as the cultivation of rice paddies, which require substantial water, can compound flood hazards, as seen in West Bengal and Assam. Inadequate drainage systems. In many Indian cities, the drainage systems are old and inadequate to handle intense rainfall events, leading to frequent urban flooding, as seen in Mumbai's annual monsoon floods. Lack of accurate data and predictive models. Accurate flood forecasting and warning systems are lacking in many regions, limiting preparedness and timely evacuation. This was a significant issue during the Bihar floods of 2008. Interstate coordination. Rivers traverse state boundaries, making flood management a multi-state issue. Often, there is a lack of coordination between states, such as between Uttar Pradesh and Bihar over the management of the Ganges, leading to inefficient flood control. Suitable way ahead in this regard. Effective land use planning. A more comprehensive and regulated approach to land use can significantly mitigate flood hazards. Urban areas like Mumbai should prioritize restoring and preserving natural drainage channels, while ensuring sustainable city expansion. Climate-smart agricultural practices. Farmers in flood-prone regions, like the Gangetic Plains, can adopt crop diversification, agroforestry, and conservation agriculture. It can help maintain their livelihoods while reducing the impact of floods. Strengthening early warning systems. Accurate and timely flood forecasting can significantly help in managing flood hazards. An advanced system, similar to the Indian Ocean Tsunami Warning System, can be developed for rivers like Brahmaputra and Ganges. Ecosystem-based management. Protecting and restoring ecosystems such as wetlands and forests can significantly contribute to flood mitigation by improving water absorption. Example: Preservation of mangroves in the Sundarbans can safeguard against floods. Interstate coordination. Effective flood management requires coordination among states sharing river systems. The Ganges River Basin states, for instance, should engage in regular dialogue and joint planning for flood control measures. Integrating climate change into planning. Flood management strategies should incorporate climate change predictions. Uttarakhand, affected by glacial lake outburst floods (GLOFs), can benefit from plans that consider future climate scenarios. Overall, managing flood hazards and maintaining ecological balance in India is a complex task. These measures, coupled with collaborative efforts from local, state, and central authorities, can go a long way in improving the flood hazard management and maintaining ecological balance in India's flood-prone regions. Q256. Elaborate on the current global frameworks and policies for mitigating ocean acidification's multifaceted repercussions on marine biodiversity, socio-economic pursuits, and geopolitical dynamics, highlighting potential areas for further improvement. 15M Core Demand of Question. Brief about the current global frameworks and policies for mitigating the multifaceted repercussions of ocean acidification. Enumerate its multifaceted repercussions on marine biodiversity, socio-economic pursuits, and geopolitical dynamics. Suggest the potential areas for further improvement. ANS. Ocean acidification is an environmental concern resulting from increased CO2 in the atmosphere. As the ocean absorbs this CO2, it forms carbonic acid, reducing water pH. This acidity threatens marine life, especially shell-forming organisms, potentially disrupting entire aquatic ecosystems and global food chains. For example, the average global ocean pH has fallen from 8.11 in 1985 to 8.05 in 2020. Current global frameworks and policies for mitigating these multifaceted repercussions. Sustainable Development Goal 14. This UN goal focuses on conserving and sustainably using the oceans, seas, and marine resources, explicitly addressing geometry and design. Compact urban layouts impede airflow and natural ventilation. Also, insufficient green spaces and shading amplify heat absorption. Climate change. Rising global temperatures contribute to the intensification of the heat island effect. A recent report released by the Intergovernmental Panel on Climate Change, IPCC, emphasized that the warming climate is exacerbating urban heat islands worldwide. Impacts on local climate, residents. Increased temperatures during the day and night, exacerbating heat waves and discomfort for example. Temperatures nearing 50 degrees Celsius were registered in 2 regions of Delhi, while the surrounding areas experienced comparatively lower temperatures. Altered precipitation patterns and reduced cloud cover, due to urban heat influence on atmospheric conditions. Changes in wind patterns and reduced natural ventilation lead to stagnant air and decreased air movement. Air quality, air pollutants. Elevated levels of air pollutants due to higher temperatures and the formation of secondary pollutants like ozone. Limited dispersion of pollutants, caused by reduced wind flow and stagnant air. Increased health risks, especially for vulnerable populations, due to poor air quality and heightened exposure to pollutants. Energy consumption, higher demand for cooling. During hot periods, increasing energy consumption and putting a strain on the power grid. It may lead to energy shortages or higher electricity costs. Increased use of air conditioning and refrigeration systems, leading to greater electricity consumption. Greenhouse gas emissions. Urban cooling demand drives energy consumption from air conditioning and refrigeration, mainly reliant on fossil fuels, releasing greenhouse gases and exacerbating climate change. Given the current scenario of rising temperatures and environmental challenges in urban areas, it is vital to address the urban heat island effect. Proactive measures like urban greening, sustainable design, and energy efficiency can help mitigate temperature impacts, enhance air quality, and reduce energy consumption. Q258. Enumerate the findings of the Global Peatland Assessment Report by UNEP. Explain how can it be a benefactor towards a better future? 10 marks, 150 words, core demand of question. Highlights of the Global Peatland Assessment Report by UNEP. Contributions of Global Peatland Assessment Report towards a better future. ANS. The Global Peatland Assessment Report by the United Nations Environment Programme, UNEP, is a comprehensive study of peatlands worldwide. Peatlands are wetland ecosystems characterized by the accumulation of partially decomposed organic matter, peat. They are wetlands with waterlogged and acidic conditions that inhibit the complete decomposition of plant material, resulting in the buildup of peat over thousands of years. Highlights of the Global Peatland Assessment Report by UNEP. Global peatland coverage. They cover approximately 3–4% of the Earth's land surface. Peatlands are responsible for nearly 1/3 of soil carbon. Draining out of peatlands. Earth loses 500,000 hectares of peatlands a year due to expansion of human activities like agriculture, industrialization, and urbanization. Release of GHGs. Also already drained and degraded peatlands contribute around 4% of annual global human-induced emissions, thus leading to global warming. Biodiversity hotspots. Peatlands are home to diverse ecosystems and support unique plant species, including specialized bog plants like sphagnum mosses, sedges, and carnivorous plants like pitcher plants and various animal species as well. Water regulation. They act as natural sponges, storing water during periods of heavy rainfall and releasing it slowly during drier periods. Indigenous peoples and local communities. For example, the Sami people in Northern Europe have a deep connection to peatlands and utilize them sustainably. Contributions of Global Peatland Assessment Report towards a better future. Climate change mitigation. The GPA report highlights the crucial role of peatlands as carbon sinks and the importance of their conservation for climate change mitigation. Adoption of nature-based solutions. The report argues for greater adoption of nature-based solutions, like sustainable peatland management, to mitigate climate change and preserve these valuable ecosystems. Awareness and understanding. The report raises awareness about the importance of peatlands in climate regulation, biodiversity conservation, and livelihood support. Policy recommendations. It suggests measures such as peatland restoration, responsible peat extraction, and improved land use planning to protect these valuable ecosystems. Promoting international cooperation. The report emphasizes the need for international collaboration, like the Global Peatlands Initiative, to bring together governments, organizations, and stakeholders to exchange knowledge and best practices. Conservation of biodiversity. The GPA report emphasizes the rich biodiversity found in peatland ecosystems and the need to protect these habitats. By promoting conservation efforts, the report contributes to safeguarding unique plant and animal species found in these peatlands. Sustainable land use. The report encourages stakeholders to adopt alternative practices that minimize environmental impacts and promote the long-term health of peatlands. Funding and investment. The report provides evidence of the benefits and potential returns on investment, making peatland initiatives more attractive to financial institutions and donors. Monitoring and evaluation. It can guide the development of monitoring frameworks and indicators, facilitating the tracking of progress in peatland conservation and restoration efforts. Overall, the Global Peatland Assessment Report by UNEP has the potential to catalyze positive change by influencing policies, raising awareness, and promoting sustainable practices that contribute to the conservation and wise use of peatland ecosystems for a better future. Q259. Interlinking of rivers comes with core objective of solving water crisis in the country. Contextually discuss the need for interlinking of rivers project in India along the lines of assessing their feasibility. 10 marks, 150 words, core demand of question. Mention the need of interlinking of rivers project in India for water management. Assess feasibility of interlinking of rivers projects. ANS. The Interlinking of Rivers ILR project is a proposed large-scale infrastructure initiative aimed at connecting rivers across the country. India's National River Linking Project, NRLP, aims to connect 14 Himalayan and 16 peninsular rivers to form a gigantic South Asian water grid. Core objective of these projects is to transfer water from excess region to deficient region, so as to bring a level of equilibrium in terms of water management. Need of interlinking of rivers project in India for water management. Water scarcity mitigation. For instance, the Ken-Betwa River Interlinking Project aims to transfer water from the surplus Ken River in Madhya Pradesh to the water-deficient Betwa River Basin in Uttar Pradesh to irrigate the drought-prone Bundelkhand region. Drought management. The Godavari-Krishna River Interlinking Project in South India aims to address water shortages in the Krishna River Basin during drought years by diverting water from the surplus Godavari River. Flood control. The The Damanganga-Pinjal River Interlinking Project in Maharashtra aims to prevent flooding in Mumbai and supply water to the city during dry periods. Hydropower generation. The Par-Tapi Nirmada Link project will be used for hydropower generation by installing small-scale hydroelectric power plants along its route, utilizing the flow of water. Ecological balance. To exemplify, the interlinking of rivers in the Chambal Basin aims to rejuvenate the once drying wetlands in that region. Groundwater recharge. River interlinking can aid in recharging groundwater reserves by transferring water to regions where groundwater levels are declining. Navigation and inland waterways. National Waterway 1 project, connecting the Ganga and Brahmaputra rivers, aims to facilitate the movement of goods and passengers. Regional development. Manas Sankash Tista Ganga River Interlinking Project in northeast India is expected to provide irrigation, hydropower, and other socio-economic benefits to the region. Feasibility of interlinking of rivers projects. Ecological considerations. For instance, different rivers have their unique aquatic ecosystem that can be disturbed by interlinking. Hydrological considerations. Understanding the availability of water resources and determining if the interlinking is feasible without causing water scarcity or ecological imbalance. Economic viability. Assess the economic benefits and costs associated with the interlinking projects, including infrastructure development, maintenance, and operation expenses. Ensuring legal and institutional framework. For instance, the Mahanadi Godavari Link project involves the states of Odisha, Andhra Pradesh, and Maharashtra and requires inter-state agreements. Assess the social implications. For instance, the Ken Betwa project involves the relocation of villages and requires adequate measures for resettlement. Technological feasibility. The proposed Himalayan Rivers Interlink project aims to divert water from the Brahmaputra River to water-scarce regions of northern India, but its feasibility requires careful assessment of technical challenges. Financial resources. Evaluate the availability of financial resources and funding mechanisms required for the implementation. The Government of India has sought financial assistance from the World Bank for the Ken Betwa project. Climate change resilience. The interlinking of the Ganges and Brahmaputra rivers in northeastern India should consider future climate scenarios and the impact of glacier retreat. Overall, the interlinking of rivers presents an opportunity to address water management challenges. But it is crucial to conduct detailed studies and assessments along with proper public participation and stakeholder engagement. Q260. Briefly describe glacial lake outburst floods, GLOF. Delineate its impact on respective regions of India and suggest some mitigative measures. 10 marks, 150 words. Core demand of question. Describe glacial lake outburst floods, GLF, in detail. Impact of glacial lake outburst floods, GLOFs, on respective regions of India. Mitigative measures to tackle these impacts. ANS. Glacial lake outburst floods, GLOFs, are sudden and catastrophic events that occur when a glacier-dammed lake releases a large volume of water, leading to a downstream flood. For example, South Lanok Lake in North Sikkim, October 2023. Glacial lake outburst floods, GLOF. Formation. GLOFs result from the natural damming of glacial meltwater by ice or moraine deposits, forming a lake behind the glacier. Triggering factors. GLOFs can be triggered by various factors, including excessive rainfall, avalanches, earthquakes, or the rapid melting of the glacier due to climate change. Flood characteristics. GLOFs are characterized by a rapid surge of water, debris, and ice downstream, causing significant destruction and posing a threat to human settlements, infrastructure, and ecosystems. Impact of glacier lake outburst floods, GLOFs, on respective regions of India. Destruction of infrastructure. To illustrate, the Chamoli Glacier burst, triggered by a GLF, resulted in the destruction of numerous roads and buildings, hampering transportation and communication. Loss of life and livelihoods. Recent study highlighted that 3 million Indians live in areas that can be swept by glacial lake floods, posing huge risk for life and livelihoods in such regions. Water scarcity. In 2023, a GLF in Sikkim's North Sikkim district caused a temporary blockade of the Tista River, affecting water supply to nearby areas. Agricultural damage. The 2015 GLF in Jammu and Kashmir's Baglihar area caused extensive damage to agricultural land, impacting the livelihoods of local farmers. Environmental degradation. The 2018 GLF in Arunachal Pradesh's Tawang district caused massive erosion and deposition of sediment in the downstream areas. Threat to biodiversity. The 2013 Kedarnath GLF in Uttarakhand led to the loss of several animal species and damage to their habitats. Disruption of hydropower projects. The 2016 GLF in Himachal Pradesh's Kinnaur district caused damage to the Baspa 2 hydropower project, leading to power outages in the region. Mitigative measures to tackle these impacts. NDMA guidelines. Identification and mapping of dangerous lakes, use of synthetic aperture radar imagery to detect changes in water bodies, and setting up of quick reaction medical teams, etc. Infrastructure development. The construction of debris flow barriers in areas like Himachal Pradesh helped prevent the destructive impact of floodwaters and debris. Community education and awareness. For example, workshops in the Kedarnath region educated locals about early warning signs and evacuation procedures. Afforestation. Planting of trees in the Nanda Devi Biosphere Reserve contributed to soil conservation and reduced the risk of landslides and subsequent flooding. International cooperation. Strengthening cooperation with Nepal for the management of the Kosi River can help mitigate the impact of GLOFs on downstream regions in Bihar. Policy integration, including GLF risk assessment and mitigation measures in the National Action Plan on Climate Change, can provide a comprehensive approach to tackle GLOFs in India. These measures, when implemented effectively, can help reduce the impacts of glacial lake outburst floods on various regions in India and protect vulnerable communities from the devastating consequences of such events. Q241. Explicate the significance of the Aravalli Green Wall in combating desertification. Highlight its socio-economic impact and examine the potential challenges associated with its implementation. 15 marks, 250 words, ANS. The Aravalli Green Wall project aims at restoring and conserving the Aravalli Range by creating a continuous stretch of greenery along the Aravalli Hills, spanning the states of Gujarat, Rajasthan, Haryana, and Delhi. Significance of the Aravalli Green Wall in combating desertification. Soil conservation. The dense vegetation cover which will be created by this wall can help bind the soil, preventing it from being carried away by wind and water. Water conservation. For instance, the increased forested areas due to the Aravalli Green Wall will contribute to the increased rainfall in the region that can ensure water supply to Delhi through the Yamuna River basin. Biodiversity conservation. This green wall will support wildlife populations like leopards, antelopes, and various bird species, contributing to the overall ecological balance. Carbon sequestration. This wall can aid in carbon sequestration, reducing the concentration of greenhouse gases in the atmosphere and combating climate change, helping India to march towards carbon neutrality. Microclimate regulation. Trees and forests created under this project will provide shade, reduce temperature extremes, and increase humidity, creating a favorable environment for agriculture and human settlements. Windbreaks. This green wall may act as a natural barrier against strong winds, preventing wind erosion and help in reducing the risk of sandstorms and dust pollution. Socio-economic impact of Aravalli Green Wall. Tourism and recreation. The scenic beauty of Green Wall will attract tourists and nature enthusiasts, contributing to the local economy. It offers opportunities for activities like hiking, wildlife safaris, and ecotourism. Livelihood support. It will provide the livelihoods to local communities through activities such as plantation drives, protecting and managing the Green Wall. Education and research. This wall can serve as a living laboratory for scientific research and environmental education and facilitate studies on ecosystem dynamics and sustainable land management practices. Fertility and agriculture. The forests created could help to maintain soil fertility to support agricultural activities in nearby areas, contributing to local food production and livelihoods. Health and well-being. It will enhance access to green spaces, promote recreational activities, stress reduction, and improved air quality, leading to better health outcomes. Potential challenges associated with the implementation of Aravalli Green Wall. Deforestation and encroachments. Unauthorized construction and land grabbing may hinder the Green Wall project due to the delays, increased cost, and destruction of vegetation. Limited water resources. In areas with scarce water supply, the lack of irrigation infrastructure may lead to low survival rates of planted saplings. Invasive species and biodiversity loss. Planting non-native species that outcompete local vegetation may result in the loss of native plant species and negatively impact the overall biodiversity of the region. Climate change impacts. Erratic monsoon patterns and prolonged droughts can put stress on newly planted trees, affecting their survival rates and overall effectiveness in creating a green wall. Land ownership and coordination. Obtaining consent and cooperation from various landowners, government agencies, and private entities can be a challenge. Funding and resource allocation. Insufficient funding may delay the establishment of necessary infrastructure, such as nurseries for seedling production, hindering the timely implementation of the Green Wall. Way forward. Watershed management. Using watershed management techniques to replenish groundwater resources, stop soil erosion, and conserve water. This involves building percolation tanks, contour trenches, and check dams. Sustainable agriculture and land use. Promoting sustainable agricultural practices that minimize soil erosion, chemical usage, and water wastage. Encouraging farmers to adopt organic farming methods and rotate crops to improve soil fertility in the region can help in replenishing Arawali Green Wall. Afforestation and reforestation. Planting native tree species in areas where deforestation has occurred and expanding the forest cover in the Arawali region through afforestation efforts will help to restore the natural habitat for wildlife and improve the overall ecosystem. Biodiversity conservation. Protecting and preserving the native flora and fauna of the Arawali region by establishing wildlife corridors and protected areas to allow for the free movement of wildlife along with prevention of fragmentation of habitats can help in making Arawali Green Wall a reality. The Arawali Green Wall will act as a crucial barrier against desertification, as well as contributing to the socio-economic development in the region. A comprehensive and collaborative approach involving government bodies, local communities, environmental organizations is needed to ensure its successful implementation. Q262. How do geopolitical rivalries influence the effectiveness of international efforts to combat climate change? Suggest some measures to mitigate these influences and enhance global climate cooperation. 10 marks, 150 words, core demand of question. Explain the influence of the geopolitical rivalries on the effectiveness of international efforts to combat climate change. Propose some measures to mitigate these influences and enhance global climate cooperation. ANS. Geopolitical rivalries characterized by competitive and often adversarial interactions stemming from diverse interests profoundly shape global relations. These rivalries significantly impact diplomacy, trade, and actions, as exemplified by the ongoing USA-China rivalry. Currently, these tensions raise worries alongside rapid global temperature rise projections suggest 2023-2027. Temperatures might elevate by 1.1–1.8 degrees Celsius above the 1850–1900 average, according to the recent IPCC report. Influence of geopolitical rivalries on the effectiveness of international efforts to combat climate change. Reduced cooperation. Geopolitical rivalries breed mistrust, curtailing cooperation for climate action. For instance, India and Pakistan's strained ties hindered collaboration on the Indus Water Treaty 1960, impacting their joint management of climate-affected shared water resources. Weakened agreements. Rivalries can undermine global climate commitments as countries prioritize self-interest. For example, the U.S. exit from the Paris Agreement in 2017, driven by nationalism and industry concerns, showcased this trend. Resource diversion. Tensions redirect resources from climate to security. For example, the Russia-Ukraine conflict shifted both nations' attention and resources away from renewable energy efforts, causing a deceleration in their transition from fossil fuels. Technology restrictions. Geopolitical rivalries can restrict clean energy technology sharing, for example. Trade limits on China impact vital solar panel components, compounding the challenge as China contributes over 80% to various stages of solar panel manufacturing. Regional fragmentation. Geopolitical rivalries can divide regions, impeding cohesive climate policies, for example. Conflicts in the South China Sea have caused divisions among ASEAN nations, hampering joint efforts to tackle climate effects like rising sea levels in the area. Competing narratives. Rival nations might exploit climate change for geopolitical gain, sowing uncertainty about its urgency. For example, during international climate negotiations, rival nations like the US and China have occasionally accused each other of not doing enough to curb emissions, undermining global unity and stalling effective climate action agreements. Inconsistent funding. Geopolitical rivalries can disrupt climate funding, potentially slowing assistance for developing nations' climate resilience through delays or reductions in contributions to initiatives like the Green Climate Fund. Measures to mitigate the influences and enhance global climate cooperation. Promote dialogue. Encourage talks solely on climate issues to sidestep broader conflicts, like India-Pakistan forming a committee to address shared water challenges, bypassing political tensions. Climate resilience bonds. Initiate financial tools for rival nations to jointly invest in cross-border climate resilience projects. For example, in the Middle East, introduce bonds for Israel and Palestine to co-fund initiatives addressing water scarcity, fostering cooperation amid rivalry. Joint climate risk assessments. Collaboratively assessing climate risks in shared regions, like the China-India borders analysis of threats such as glacial melting and water scarcity, can promote adaptive strategies and cooperation amid geopolitical tensions. Climate-smart trade agreements. Integrate climate aims into trade pacts, offering tariff reductions for eco-tech collaboration. For example, the US and China could lower clean energy tariffs in exchange for joint work on carbon-neutral transportation. Virtual reality diplomacy. Use VR simulations for climate talks, helping rival leaders collaborate remotely. For example, India-Pakistan could employ VR to overcome geographical obstacles in climate negotiations. Climate cybersecurity pacts. Create agreements among rivals to safeguard climate data from cyber threats. For example, the United States and Russia could jointly secure data exchanges, ensuring trust despite geopolitical tensions. Green innovation exchanges. Establish cross-border hubs for joint green tech projects, such as creating a Taiwan-China hub that fosters renewable energy collaboration, driving progress and promoting mutual understanding. In the realm of addressing climate change, geopolitical rivalries cast shadows on collaboration. However, the fusion of innovation and cooperation offers avenues to overcome challenges, liberating nations from rivalry's limits to jointly address the urgent global climate crisis and forge a united effort to protect our planet, transcending geopolitical discourse. Extra edge. The interplay between cooperation and conflict is evident within the United Nations Framework Convention on Climate Change, as demonstrated during COP26 in 2021, where India and China collaborated to shift the global commitment from coal phase-out to a more gradual coal phase-down in the final agreement. Q263. Exploring the geographical distribution of major oil-producing nations. Examine the environmental concerns linked to oil production within these nations. 15M Core Demand of Question. Provide the geographical distribution of major oil-producing nations. Discuss the environmental concerns linked to oil production within these nations. Propose some effective strategies for sustainable oil production. ANS. Oil, the lifeblood of industrialized nations, has been the world's primary energy source since the mid-1950s. It fuels powering industries, heating homes, and propelling vehicles and aircraft that connect the global community. However, global oil production is highly uneven. Presently, approximately 80.4%, 1,241.82 billion barrels, of the world's proven oil reserves are concentrated in OPEC member countries, with the majority, 67.1%, found in the Middle East. Geographical distribution of major oil-producing nations. Middle East. Slightly less than half of the world's proven oil reserves are located in this region. Saudi Arabia. It has second-largest proven oil reserves in the world, 17%. Iraq, Kuwait, Iran. Each estimated to have 25% of all proven oil reserves in the world. Al Burkan oil field, Kuwait, is the world's second-largest oil field. United Arab Emirates, UAE. It ranks among the top 10 oil-producing nations globally. Approximately 96% of the nation's extensive proven oil reserves, which amount to roughly 100 billion barrels, are situated in Abu Dhabi, placing it sixth in the global rankings. Qatar. According to the Oil and Gas Journal, Qatar possesses approximately 11% of the world's confirmed natural gas reserves and nearly 30% of the reserves found in the Middle East. Oman. It stands as the most prominent oil producer in the Middle East that is not a member of the Organization of Petroleum Exporting Countries, OPEC. Russia. It ranks as the world's third largest oil producer, over 12% of global crude oil production, trailing only the United States and Saudi Arabia in production. United States. As of 2023, the United States maintains its status as the foremost global producer of crude oil, a position it has maintained since 2018. Its confirmed oil reserves constitute 2% of the global aggregate. Canada. It ranks third globally in terms of oil reserves and holds the position of the fourth largest oil producer in the world. Venezuela. With the world's largest oil reserves, totaling more than 303 billion barrels, Venezuela is the fourth largest oil producer in Latin America. Brazil. In 2022, Brazil secured the 9th position in global oil production with an average daily output of slightly more than 3 million barrels. United Kingdom. In 2022, the UK sustained its position as a significant oil and gas producer, contributing 0.8% to the global production. This, however, marked a nearly 11% decrease compared to the oil production reported in 2021. African region. As of 2022, Nigeria held the top position as Africa's primary oil producer, with an annual oil production of approximately 69 million metric tons. Following closely were Libya, Algeria, and Angola, each surpassing the 50 million metric tons mark in oil output. Environmental concerns linked to oil production within the above nations. Spills. Oil production in these nations can lead to accidental spills, releasing large quantities of crude oil into the environment, which can have devastating impacts on aquatic ecosystems, coastal areas, and local communities. For instance, the Deepwater Horizon oil drilling platform in the Gulf of Mexico exploded in 2010, resulting in the largest oil spill in offshore drilling history. Air pollution. The oil industry's operations contribute to air pollution through the release of harmful emissions, including sulfur dioxide and nitrogen oxides, which can lead to respiratory problems and smog formation in nearby regions. For example, gas flares from Venezuela's formerly blooming oil sector are causing pollution in nearby towns. Water contamination. Oil production activities can contaminate water sources, such as rivers and groundwater, posing risks to aquatic life and affecting the availability of clean water for local populations. For example, in 2013, Pennsylvania, USA, recorded 398 complaints reporting that drilling activities related to oil or natural gas had led to contamination or other impacts on private water wells. Greenhouse gas emissions. Oil production releases significant amounts of CO2 into the atmosphere, a major greenhouse gas. This occurs due to various activities such as fossil fuel burning to generate electricity and power vehicles, as well as the operation of machinery. For example, according to IEA, the production, transport, and processing of oil and gas resulted in 5.1 billion tons (GT) CO2 EQ in 2022. Land degradation and deforestation. Extensive drilling and infrastructure development associated with oil production can lead to soil erosion and diminish the quality of land for agriculture. Additionally, deforestation occurs as land is cleared for drilling sites and infrastructure. For example, in the USA, more than 12 million acres of public lands are allocated for fossil fuel production. Some effective strategies for sustainable oil production. Enhanced oil recovery, EOR techniques. Implement advanced EOR methods to maximize oil extraction from existing fields while minimizing environmental impact. For example, in the United States, CO2 is injected into oil reservoirs to enhance oil recovery while sequestering carbon underground. Reducing flaring and venting. Minimize the flaring and venting of associated gas during oil production. For example, Norway has successfully reduced flaring emissions by more than 80% since the mid-1990s through strict regulations and the development of gas infrastructure to capture and utilize associated gas. Improved water management. Implement efficient water management practices to reduce the environmental impact of oil production. For example, in Canada, oil sands operators are using water recycling and advanced treatment technologies to minimize water use and reduce the release of contaminated water into the environment. Biodiversity conservation. Protect and restore natural habitats and biodiversity in oil-producing regions. For example, Ecuador's Yasuni National Park is an example where a portion of the country's oil reserves is left untapped to preserve the park's unique biodiversity. Transition to renewable energy. Invest in renewable energy sources and technologies to reduce dependence on fossil fuels and mitigate the environmental impact of oil production. For example, the UAE, despite being a major oil producer, is investing in solar energy projects to diversify its energy mix and reduce greenhouse gas emissions. The geographical distribution of major oil-producing nations highlights the concentration of resources in specific regions, shaping the global energy landscape. However, environmental concerns linked to oil production raise concerns about the sustainability of this vital industry. As the world continues to rely on oil, the imperative to balance production with environmental preservation becomes increasingly urgent. Extra edge. Each year, approximately 1.3 million tons of crude oil are introduced into global waters. In the case of the Persian Gulf, one of the world's most vital bodies of water, this figure equates to 300 tons.